Yeah, let us look at a simple example. There is an object being pulled to the west with 10 Newton, and there is a friction 3 Newton to the east. So the work done by these two forces are as follows. So work done by applied force, that is 10 times 3 times cos 0. So that is going to be 30 joules positive work. And let us look at the work done by the frictional force, that is 3 Newton times 3 meters times cos 180. So you can see that the work done by the frictional force is negative 9. So remember, I already mentioned that work is a scalar quantity. So how do we account for the negative sign? So this is what we must understand there. Positive work means the work which increases the mechanical energy of the object or the system. And the negative work means the work which decreases the mechanical energy of the system. Actually, friction is a dissipative force which take out the energy from the object or the system to the surroundings in the form of heat energy or sound energy, etc. Therefore, the net work done is, you can see, 30 plus negative 9, which is 21 joules. I hope you understood what is meant by the negative work. Now, let us concentrate on the next. We have to look at the work energy theorem. So, before we go to work energy theorem, let us look at a situation where the object is pulled by a force which makes an angle theta to the horizontal. So you can see that here, not the whole force is doing the work, only the force which causes the object to move in the horizontal direction are doing the work. Therefore, we have to calculate the horizontal component of the force first, which is equal to, you can see, Fx. The horizontal component is equal to F times cos theta. Therefore, the work done is going to be W Fx times delta x times cos theta. And on elaborating it, you can see F cos theta times delta x times cos theta alone again. So the first cos theta, this one, is the angle between the force and the horizontal, and this theta is the angle between the force causing the work and the direction of displacement. So you see, so we use theta, but those theta are representing two different angles. Be aware of that. So in short, when we calculate the work done by a force which makes an angle theta to the horizontal is calculated like that. So be aware of that. So it should be therefore Fx times delta x times cos theta. Okay, let us look at another thing. Before we move to the work energy theorem, there are two definitions you must be very much sure of. You see, the forces are generally, forces, we categorize it in different ways, but here there are two categories of forces. There is a conservative force and there is a non-conservative force. So if the work done by a force does not depend on the path taken, then that is a conservative force. Example is gravity. So gravity is a conservative force. Then the other one is non-conservative force. So if the work done by a force depends on the path taken, then definitely that force is a non-conservative force. You see, the forces we come across like applied force, tension, applied friction, etc. are examples of non-conservative force. So I hope it is clear. So for more clarity, please refer the textbook. There is a section